This is SpaceTime, Series 26, Episode 156, for broadcast on the 29th of December 2023. Coming up on SpaceTime, Equatorial Launch Australia unveils its plans for new spaceport launch pads. Rocket Lab's back in business following successful Electron launch from New Zealand. And North Korea has launched its biggest intercontinental ballistic missile so far. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Equatorial Launch Australia has unveiled its final plans for its spaceport launch pads at the Arnhem Space Centre east of Darwin. The new pads are specifically designed to accommodate multiple rocket designs with minimal modification. The new design can handle all current New Space small launcher rocket types with masses up to 450 tonnes and payload capacities of up to 3 tonnes. The new pads feature 90-degree triple redundancy hydraulically controlled pivot bases. Each is equipped with a custom-designed interface plate element allowing rapid mounting and dismounting of different launch vehicles and support equipment. The new pads are also designed to reduce rocket plume damage by using a multi-layer composite plume deflector engineered to handle high-velocity rocket plumes exceeding 16,500 km per hour and temperatures over 4,000 degrees Celsius. The launch pads also feature an 80,000-litre water deluge system to mitigate the thermal and acoustic effects of the launch. Complementing the new launch pads will be a launch vehicle transport system to carry rockets from the horizontal integration facility. The rocket trolley, as it's called, is designed to handle launch vehicles up to 45 metres long, weighing in excess of 130 tonnes empty. The new launch pad design follows confirmation that a South Korean company has already signed up to be one of the first long-term tenants of the facility. Equatorial Launch expects to accommodate up to 7 launch companies at the complex. Back in 2022, the company successfully launched 3 NASA suborbital 2-stage Black Brant 9 sounding rockets. The June 26th launch carried the X-ray quantum calorimeter experiment for the University of Wisconsin. The July 6th launch carried the suborbital imaging spectrograph for transition region irradiance of nearby exoplanet host stars, or SISTENE mission for the University of Colorado Boulder. And the July 11th launch carried the dual-channel extreme ultraviolet continuum experiment JUICE, also for the University of Colorado Boulder. The 3 flights mark NASA's first launches from Australian soil since 1995, when missions were conducted from the Woomera rocket range in outback South Australia. This is SpaceTime. Still to come, Rocket Lab are back in the space launch business following a successful mission from New Zealand. And North Korea flexes its muscle as it launches its biggest intercontinental ballistic missile ever. All that and more still to come on SpaceTime. Rocket Lab has returned to flight status, successfully launching an Electron rocket from its Mahia Peninsula spaceport on New Zealand's North Island. The mission, named the Moon God Awakens, carried the Tsukuyomi-1 satellite into orbit for Japanese startup Institute of Kyushu Pioneers of Space Incorporated. The synthetic aperture Earth observation satellite is named after a Japanese god of the moon. The launch was the 10th Electron flight this year, beating the company's previous record of 9 set in 2022. And it was also the 42nd Electron launch for the company.
Avionics batteries have switched to internal power. Ground power is disabled, vehicle is fully on internal power. AFTS is green and enabled for flight.
LOX load is complete, system is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed.
High flow engine purge enabled.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, liftoff.
Electron has lifted off from Launch Complex 1 and we are 34 seconds into our flight. With Electron now clear of the pad, soon we will approach max Q, or maximum aerodynamic pressure. the moment of the most amount of stress against the rocket.
Vehicle supersonic, approaching max Q.
High voltage discharge nominal.
Cleared max Q.
And there you have it, Electron has cleared max Q. A beautiful and nominal mission so far, now up 15 kilometers in altitude as the rocket reaches speeds of more than 2,100 kilometers.
Next up are 3 mission milestones that happen in quick succession. First up, we have MECO, or main engine cutoff. This has been all 9 Rutherford engines on the first stage throttled down and then shut off completely. Very quickly after that, we have the separation of the first and second stages. Main booster tank fall away from Electron's second stage. We then have the ignition of the single Rutherford engine on Electron's second stage, as the mission continues to orbit. Those calls should be coming up from our operators and mission control very shortly.
Stage 1 propulsion holding nominal. Stand by for MECO.
15 seconds to MECO.
Entered burnout detect mode.
MECO confirmed.
Stage separation successful.
Stage 2 ignition confirmed.
As you can probably tell from that applause, we have had a successful MECO, stage separation and second stage engine start for Electron. Up next will be the fairing jettison, where the 2 halves of Electron's protective fairing split and fall away from the vehicle to expose IQPS's satellite to space in preparation for payload deployment.
Fairing jettison succeeded.
At 3 minutes and 42 seconds into the mission, the single Rutherford engine on Electron's second stage continues to burn bright as we make our way to orbit.
High voltage.
The engine's nozzle includes a nitrogen bottle, which has been introduced as part of an update to the second stage system. Now, this is providing pressurized gas to the enclosure covering the second stage electrical system, helping to minimize the chances of electrical arcs.
Stage 2 propulsion nominal.
Soon we'll reach a mission milestone unique to Electron, the battery hot swap. Electron's fuel pumps are battery powered, and once we deplete the first set of batteries, they're of no use to us anymore, and so we swap them out with a fresh set, ejecting the depleted ones so that they don't hitch a ride to orbit.
We are now 4 minutes and 42 seconds into flight and well on our way to orbit. Now, attached to Electron's second stage is the kick stage, IQPS's satellite right there, which is poised for deployment to a 575 kilometer orbit. We have about 61% of propellant remaining, which will take us through to about T plus 9.5 minutes, where we will have engine shutdown and kick stage separation.
The Stage 2 Rutherford engine continues to perform nominally, and Electron is climbing steadily to its target apogee of 575 kilometers above Earth. The IQPS payload atop the kick stage is less than an hour away from its home in orbit.
Throttling down.
HVB discharge nominal. Hot swap successful.
That was the call. That battery hot swap is confirmed and the mission is proceeding as planned. In about 3 minutes, Electron's second stage will experience SECO, or second engine cutoff. Now, much like main engine cutoff, the Stage 2 Rutherford will throttle down before the kick stage separates as it continues on to payload deployment.
HVB battery discharge holding nominal.
All right, a quick check in on the dials at T plus 7 minutes and 28 seconds. Electron is traveling at a speed of over 17,000 kilometers per hour and approaching an altitude of about 242 kilometers, which with some quick maths brings us another 300 or so kilometers to go in this mission. Now, after we reach that target, we will have a coast phase of about 45 minutes as the kick stage scoots around the other side of Earth and back into position, ready for payload deployment.
Stage 2 propulsion still holding nominal.
The team in Mission Control are closely monitoring the Stage 2 burn as we get closer and closer to SECO, or second engine cutoff. Just a minute to go until that milestone, with Electron and the IQPS payload remaining healthy. Reminder that this version of Rutherford is designed for the vacuum of space, so the glowing nozzle is much larger than the sea-level variant of the engine used on Stage 1. This large nozzle extracts more energy from the exhaust as it expands, increasing the performance of the engine.
Entered burnout detect mode.
Guidance is internal, 25 seconds remaining.
As we mentioned before, one of the final milestones coming up for this mission is SECO. The second stage engine throttled down ahead of shutoff, then the kick stage, which the satellite is attached to, will separate and begin its coast phase. So let's listen in to Mission Control for the calls.
SECO confirmed.
Nominal transfer orbit achieved. And Stage 3 separation confirmed.
And with that, the Rutherford engine on Electron's second stage has successfully shut down, and Stage 2 and the kick stage have cleanly separated. The kick stage will now enter what we call a coast phase. For the next 45 minutes or so, the kick stage will be in an elliptical orbit around Earth before the Curie engine ignites, raising the kick stage's perigee to put us in a circular orbit. From here, we will deploy IQPS's Tsukuyomi satellite to its destination in orbit.
Rocket Lab's 42nd Electron launch, a dedicated mission for IQPS.
There's a few more seconds left in this burn, then the engine will shut down and the moon god will awaken. Let's hand it back over to Mission Control as we listen in for those final calls.
Curie engine cutoff confirmed.
That's confirmation from Mission Control. The Curie engine has shut down. We are about 40 seconds away from payload deployment of the Tsukuyomi satellite, ready to join the other QPS SAR-5 satellite already in orbit.
Payload deployment confirmed.
You heard it there from Mission Control and from the applause from our team. Payload deployment is confirmed. The moon god has awoken and Tsukuyomi is now in orbit, ready to perform its mission to provide Earth observation imagery in rain, hail, or shine.
Rocket Lab have 2 launch pads at Mahia and a third at NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast. And as well as Electron, it's now building a new rocket design, even bigger and more reusable, called the Neutron. The Moon God Awakens mission was the first Electron flight since the September 19 launch failure, when the rocket's second stage suddenly shut down shortly after stage separation, 2.5 minutes after liftoff. An investigation into the incident by Rocket Lab and the US Federal Aviation Administration pointed to an electrical arc in the power supply system, which provides high voltage to the Rutherford engine's motor controllers. And that shorted out the battery packs, which provide power to the launch vehicle's upper stage. This is SpaceTime. Still to come, North Korea launches its biggest intercontinental ballistic missile, one large enough to reach any point in the United States. And in January, Skywatch, the Earth enters perihelion, a look at Sirius the dog star and the brightest star in the night skies, and the Quadrantids Meteor Shower are among the highlights of the January night skies on Skywatch. North Korean dictator Kim Jong-un has vowed to accelerate the country's nuclear build-up after overseeing the launch of the solid-fueled Hwasong-18, Pyongyang's biggest and most powerful ballistic missile so far. Kim says the new missile is capable of reaching anywhere in the United States, confirming reports by Japan's defense ministry, which claimed the Hwasong-18 had a potential range of more than 15,000 kilometers, allowing it to quite literally cover the entire continental United States. On this test flight, the Hwasong-18 flew just over 1,000 kilometers, reaching a maximum altitude of 6,000 kilometers. The flight was the third test of a North Korean solid-fueled ICBM after launches in April and July this year, which analysts say are signaling consistent efforts to improve the technology. The United Nations Security Council has adopted numerous resolutions calling on Pyongyang to halt its nuclear and ballistic missile programs since its first nuclear test back in 2006. North Korea has carried out 6 nuclear tests so far, the most powerful with an estimated yield of somewhere between 100 and 370 kilotons back in September 2017. A report by the US Congressional Research Service estimates that North Korea now has enough enriched uranium for between 20 and 60 nuclear warheads. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for January on Skywatch. January is the first month of the year in the Julian and Gregorian calendars. The name originates in the Latin word for door. That's because January is the door to the new year and an opening to new beginnings. The month is conventionally thought of as being named after Janus, the mythical Roman god of beginnings and transitions. But according to the ancient Roman farmer's almanac, it was actually Juno who was the traditional god of January. Of course, from an astronomical point of view, January marks Earth's closest orbital position to the Sun, perihelion, which occurs about 2 weeks after the December solstice. Planets, including the Earth, don't orbit the Sun in perfect circles, but rather in ever-changing elliptical orbits. The shape of these orbits vary due to gravitational influences from other planetary objects. And in Earth's case, that especially includes the Moon, which is almost massive enough to be considered a binary partner. So, over a roughly 100,000-year cycle, Earth's orbit changes in shape from almost circular to far more elliptical. This difference is known as eccentricity, and the nearest point in Earth's orbit around the Sun is called perihelion. This year's perihelion will occur on Wednesday, January the 3rd at 11:38 a.m. Australian Eastern Daylight Time, when the Earth will be just 147,100,632 kilometres from the Sun. That's 7:38 in the evening of Tuesday, January the 2nd, US Eastern Standard Time, and 38 minutes after midnight on Wednesday, January the 3rd, Greenwich Mean Time. Around 6 months later, and about 2 weeks after the June solstice, Earth will be at its furthest orbital position from the Sun, a location known as aphelion. Okay, let's start our tour of the January night sky by looking to the northeast, right next to the constellation Orion, where you'll see the brightest star in the night sky, the dog star Sirius. So called because it's the brightest star in the constellation Canis Major, the big dog. The name Sirius actually means scorching or brilliant, a clear reference to its spectacular brightness in the sky. As well as being one of the nearest stars to the Sun at just 8.7 light years, it's also intrinsically bright, and almost twice as bright as the second brightest star in the night skies, Canopus. A light year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Sirius is the fifth closest star to the Sun, and it's gradually moving closer to the solar system, so it'll steadily increase in brightness over the next 60,000 years, after which time it will begin moving away again, and it will gradually become fainter and fainter. But it will still continue to be the brightest star in Earth's night sky for at least the next 210,000 years. Sirius is a binary star system comprising a spectral type A main sequence white star called Sirius A and a small white dwarf companion Sirius B, which orbits between 8.2 and 31.5 astronomical units away from the primary star. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres. Main sequence stars are those undergoing hydrogen fusion into helium in their core. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue white stars, then spectral type A white stars, spectral type F whitish yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive stars known are spectral type M red stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together, and our Sun becomes a G2V or G25 yellow dwarf star. Also included in the spectral classification system are spectral types LT and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest stars, those spectral type M red dwarfs we talked about before, which are about 75 to 80 times the mass of Jupiter, or around 0.08 solar masses. Brown dwarfs don't have enough mass to build up the sorts of temperatures and pressures in their cores needed to trigger the nuclear fusion process which makes stars like our Sun shine. Sirius A has at least twice the mass of the Sun and is about 25 times more luminous. The Sirius binary system is between 200 and 300 million years old, quite young by astronomical standards, and it originally consisted of two bright spectral type A white stars. The more massive of these two stars, Sirius B, consumed its resources and became a red giant before shedding off its outer layers and collapsing into its current state as a white dwarf around 120 million years ago. White dwarfs are the stellar corpses of Sun-like stars. Stars shine by fusing hydrogen in their core into helium. When these stars run out of hydrogen, hydrostatic equilibrium, that is, the balancing act between the outwards push of nuclear energy and the inwards pull of gravity ceases, and gravity wins, causing the star's core to dramatically contract and compress under its own gravity. As the star's contracting, regions around the stellar core which still contain hydrogen are moved closer to the core and the region where pressures and temperatures allow hydrogen fusion to take place. This triggers hydrogen burning in the shell around the core, causing the star's outer layers to dramatically expand, and being further away from the core, the star's photosphere or visible surface gets cooler and looks redder. The star, now called a red giant, experiences a massive increase in its stellar wind production as more and more material flows out of its gaseous envelope. Meanwhile, the increase in pressure and temperature caused by the core contracting eventually triggers what's called a helium flash, fusing the core helium into carbon and oxygen. Now, higher mass stars will then progress to fuse heavier and heavier elements. But smaller stars like the Sun don't contain enough mass to fuse carbon and oxygen into heavier elements, and so stellar fusion comes to an end. The star's outer gaseous envelope drifts away as a spectacular planetary nebula, leaving exposed the super-dense white-hot stellar core, a white dwarf, which will then slowly cool over the eons. In trillions of years' time, it'll cool down enough to become a black dwarf, but the universe hasn't been around long enough for that to happen to any white dwarf yet. The atmospheres of white dwarfs are composed mainly of hydrogen and helium, but between 25 and 50% of all known white dwarfs also show traces of metals in their spectra. Astronomers refer to all elements heavier than hydrogen and helium as metals. These metals originate through the accretion of tidally disrupted planets that were previously orbiting the progenitor star, but were consumed by the star as it expanded out into a bloated red giant. And of course, this will also be the fate that ultimately befalls our own local star, the Sun, in about 7 billion years from now, and with it, the Earth itself. 5,000 years ago, the ancient Egyptians looked at Sirius and they saw it as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and who guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Anubis was later replaced in Egyptian mythology by Osiris as the lord of the underworld, and Sirius became the goddess Isis. By carefully watching Sirius's movements across the sky, the ancient Egyptians determined that it would be visible every night for 295 and a quarter nights, followed by 70 nights of absence. And this allowed them to determine that a year was 365 and a quarter days long. Their calculations were accurate to within 11 minutes. The helical rising of Sirius also marked the annual flooding of the River Nile in ancient Egypt and the hot, sultry dog days of summer for the ancient Greeks. In Greek mythology, Sirius was the dog star and the canine companion of Orion the hunter. Helical rising refers to the first time of the year when a star becomes visible above the eastern horizon for a brief moment just before sunrise. It's been claimed that the Dogon people in Mali in Western Africa have ancient stories describing the 50-year orbital period of Sirius and its companion white dwarf, which predate the white dwarf's discovery by modern astronomers. It's also claimed that these legends were handed to the Dogon people by ancient aquatic space travelers who told them of a third star accompanying Sirius A and B. However, a report in the journal Current Anthropology raised serious doubts about whether the stars referred to by the Dogon people were in fact Sirius A and its white dwarf companion. That's because senior Dogon claim the story actually refers to a different grouping of stars. Also, other researchers have pointed out that the Dogon could have heard about the discovery of Sirius's companion and then simply incorporated it into their mythology in 1893 when a French expedition arrived in Central West Africa to observe an April 16 total eclipse and were overheard discussing the discovery. Looking due north just above the horizon this time of year, and you'll see the bright yellowish star Capella, the brightest star in the constellation Auriga the Charioteer. Capella is the Latin term for a small female goat. The star's alternative name is Capra, which was more commonly used in classical times. Although it appears to be a single star to the unaided eye, Capella is actually a system of 4 stars in 2 binary pairs. The first pair comprises 2 bright yellow giant stars, both of which are around 2.5 times the mass of the Sun. Having exhausted their core hydrogen supplies, both stars have cooled and expanded out to become giants, moving off the main sequence. Designated Capella AA and Capella AB, they're in a very tight circular orbit, some 0.76 astronomical units apart, orbiting each other every 104 Earth days. Capella AA is the cooler and more luminous of the two, with some 78 times the luminosity and 12 times the radius of the Sun. Known as an aging red clump star, Capella AA is fusing helium into carbon and oxygen in its core. Capella AB is a slightly smaller but hotter subgiant, about 73 times as luminous and almost 9 times the radius of the Sun, and it's in the process of expanding out to become a red giant. The Capella system is one of the brightest sources of X-rays in the sky, thought to come primarily from the corona of the more massive giant. The second pair of stars in Capella are located about 10,000 astronomical units from the first pair. They consist of 2 faint, small, relatively cool spectral type M main sequence red dwarf stars. The 2 red dwarfs have been designated Capella H and Capella L. Now, almost directly overhead this time of year, a position in the sky known as zenith, we find Canopus, the second brightest star in the night sky after Sirius. Located some 313 light-years away in the constellation Carina the Keel, Canopus looks incredibly bright because it is huge. It's a giant spectral type A white star, with some 10 times the mass, 71 times the diameter, and 10,000 times the luminosity of the Sun. Canopus is another bright X-ray source, also most likely produced by its corona, magnetically heated to several million Kelvin. The temperature is also likely to be stimulated by fast rotation combined with strong internal convection currents percolating through the star's outer layers. No star in our night sky closer than Canopus is more luminous than it, and it's been the brightest star in Earth's night sky during 3 different epochs over the past 4 million years. Other stars appear brighter only during relatively temporary periods, during which they're passing the solar system at much closer distances than Canopus. About 90,000 years ago, Sirius moved close enough that it appeared to be brighter in our night sky than Canopus, and as we mentioned earlier, that'll remain the case for another 210,000 years. But in 480,000 years from now, Canopus will once again be the brightest star in the night sky, and it will remain so for a period of about 510,000 years. In Greek mythology, Canopus was a helmsman and the navigator for the fleet of Menelaus, king of Sparta, which was sailing back from the Battle of Troy. Canopus is said to have died when the fleet arrived at the port of Alexandria in Egypt, and so a star which was visible on the horizon was named in his honour. Now, as we said, it's the brightest star in the constellation Carina, which represents the keel of the boat Argo, used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin or poop deck, which is represented by the constellation Pappus. Canopus forms part of the stellar association or asterism known as the False Cross, which straddles the constellations Carina and Vela the sails and is often confused with the real Southern Cross or Crux. Combined, Carina, Vela and Pappus used to form the constellation Argo Navis, representing the ship Argo skimming along the river of the Milky Way. But modern-day astronomers consider the constellation to be simply too big because it was some 28% larger than the next biggest constellation, and it had more than 160 easily visible stars. And so it was eventually divided into the 3 smaller constellations, Carina, Vela and Pappus, in 1755. This time of the year, the Southern Cross is upside down, low down in the southern skies during the early evening. For our listeners north of, say, Brisbane, it'll most likely be hidden by trees and buildings on the horizon during the early evening. But later on, as the Earth turns, the Southern Cross will rise above the horizon in the south-southeast for our northern listeners and appear to be lying on its left side. One of the best things about living in the southern hemisphere is that most of the brightest stars in the night sky are visible during January nights. Sirius the dog star is the brightest, followed by Canopus the navigation star. Third brightest is Alpha Centauri, the furthest of the 2 pointer stars pointing to the Southern Cross, and the nearest star system to the Sun. The 4th and 5th brightest stars, Arcturus and Vega, aren't visible in the southern hemisphere during January. But the 6th brightest, Capella, is visible just above the northern horizon. And the 7th, Rigel, marks Orion's knee. Next, in 8th place, is Procyon the little dog. And 9th is Achernar, at the end of the river Eridanus. Finally, there's Betelgeuse, Orion's shoulder, the 10th brightest star in the night sky. So, that's 8 of the 10 brightest stars in the night sky, all visible at once on a warm summer's evening in the southern hemisphere. January also plays host to one primary meteor shower, the Quadrantids. Most meteor showers radiate out from a recognizable constellation, like Leo's Leonids or Gemini's Geminids or Orion's Orionids. But the Quadrantids are meteors that appear to radiate out from the location of the former Quadrans Moralis constellation. In the early 1920s, the International Astronomical Union divided the sky into 88 official constellations. However, that means more than 30 other historical constellations didn't make the cut. The Quadrans Moralis area of the sky falls within the boundaries of the official constellation Bootes. The radiant point of the shower is near the Big Dipper, between the end of the handle and the quadrilateral of stars marking the head of the constellation Draco. The Quadrantids are usually one of the year's most spectacular meteor showers, with up to 8 meteors per hour. They're best seen from the northern hemisphere, and unlike other meteor showers which tend to peak for at least a day or two, the Quadrantids only peak for a couple of hours. While most meteor showers are produced by the Earth passing through debris trails left behind by comets, the Quadrantids are one of only 2 meteor showers known to be produced by asteroids. They're associated with the asteroid 2003 EH1, which is thought to be the remains of a cometary nucleus that fragmented and broke apart centuries ago. EH1 still circles the Sun in a 5.5 Earth-year-long elongated comet-like orbit, which extends out beyond Jupiter. The progenitor is thought to be the comet C1490Y1, which was first observed by Chinese, Japanese and Korean astronomers 500 years ago. It was classified as an asteroid when it was discovered by a near-Earth asteroid telescopic survey in 2003. The only other major meteor shower associated with an asteroid are the Geminids, which occur in December and are caused by debris left behind by the asteroid 3200 Phaeton, which is also thought to be the remains of a comet. Jonathan Nally from Sky and Telescope magazine joins us now for the rest of our tour of the January night skies.
G'day, Stuart. Yeah, January. So for us down here in the Southern Hemisphere, it's midsummer, which means beautiful weather for observing. It does mean shorter hours of night time, though. So the days are longer and the nights are shorter, but the weather's good. So those hours, you can get a lot of stuff done if you're a stargazer in the summer. So if you're looking for the Southern Cross, which is the thing that most people want to see when they come to the south, it's still more or less upside down at the moment, low down on the southern horizon. But as the night goes on and the Earth rotates, Southern Cross will rise higher and higher until sort of late evening, getting on towards midnight. You'll see it sort of lying on its left-hand side down in the southeast. It's actually a very small constellation. People expect to see something really huge, and they don't spot it. They say, "Where is it? Where is it?" And when you point out that it's really quite tiny, they go, "Oh yeah, it's really small," but the stars are quite prominent. They're quite bright. So once you get the hang of it anyway, you always are then able to find the Southern Cross. The Milky Way, which is just our galaxy seen from the inside, of course, is stretching right across the sky from the south to the north, and its star fields contain some really great constellations and what astronomers call deep sky objects, those things like star clusters and those big nebulae, those colourful clouds that float around in space. So starting down in the south, we've got the Southern Cross that's in the Milky Way. Then we come to the constellations Carina and Vela and Puppis and Canis Major. And if we keep going north, we eventually end up to Orion and Gemini and Taurus. Now, some of those constellation names people will have heard before. Others they might not have, because there are 88 constellations up there and only, 12 are the Zodiac. There should be a 13th, of course, Ophiuchus. But 76 constellations up there most people have never heard of. And, of course, they just sort of join the dot affairs in the sky. People a long time ago wanted to put a particular mythological figure or some sort of object into the starry heavens, and so they sort of joined the dots sort of thing, and so that looks roughly like this, or that looks roughly like that, like a fish or this or whatever, or a river. There's a constellation called Eridanus, which is just a big long, literally just a big long join the dots affair, stretches right from the northern sky down the southern sky, and it's just a river. It's just one long linear thing with lots of kinks and bends in it, of course. So anyway, that's what's up there in the sky if you're into constellations. So all of those ones I just mentioned anyway, they've got amazing star fields, star clusters and nebulae, all of which can be enjoyed just with a pair of binoculars. You don't need a telescope for some of this stuff. In fact, for a lot of it, a pair of binoculars is perfectly good. But also, if you've got nice dark skies that you're looking from, then just use your own eyes to sweep along the Milky Way, and there's plenty of stuff to see. Now, more or less directly north in the mid to late evening in January, that is north if you're looking from the southern hemisphere, is a tiny clump of stars called the Pleiades, or the Seven Sisters, which we've spoken about lots and lots of times in the program. It's a cluster of about 1,000 stars, quite a long way from Earth, and for us here, this distance to the naked eye, under dark skies, with dark adapted eyes, you can see about 6 or 7 stars. That's why they call it the Seven Sisters. Some people claim to be able to see 10 or 11. I certainly can't see that with my eyesight these days. But if you get a pair of binoculars onto this star cluster, then you will see more stars. It really is super pretty. It really is lovely if you get a chance to see that. Back down in the south again, we've got 2 galaxies that you can see with the unaided eye. as long as you don't have too much light pollution around, such as nearby streetlights and things. These two galaxies are the small and the large Magellanic Clouds, and they've been famous for many, many years. And they've been known since antiquity by all the indigenous peoples of the southern part of the planet. They're named Magellanic after Ferdinand Magellan, because when he was leading the expedition, about 1519, I think they left, and some of his ships eventually got back 1522, I think. He didn't make it all the way. He was killed in the Philippines in April 1521, I think the date was. So someone else took over and led the expedition for the rest of it. But it was on that voyage that the person on board, who was sort of the astronomer, took note of these wispy, cloudy things in the southern sky and thought, oh, that's interesting. They got named after the boss, of course, not after this astronomer. And actually, there's a bit of a push on at the moment by some astronomers to rename these two galaxies, take the name Magellanic Clouds off them and call them something else, because during that voyage, Ferdinand Magellan led, a lot of indigenous people got killed along the way and were mistreated along the way. And they also say that was the voyage that then sort of opened up the way for the Spanish to come into South America. And of course, there's all that history there with that. So some people are suggesting that they should be renamed, these things. And one name I've seen suggested is just the Milky Clouds. So we have the Milky Way galaxy that we live in, and these two nearby galaxies might just be called the Milky Clouds. But anyway, that's a bit of a push on for that at the moment, but nothing's been settled. Now, here's something interesting. If you go out and look at the sky around midnight during January, you'll be able to see the first, second and third brightest stars in the whole sky, not counting the sun, of course. I mean, you can see these three stars for a span of a couple of months, really, but this is a good time of year to see them. And they are respectively the stars Sirius, Canopus and Rigel Kentaurus. That's a name people might not have heard before, and they might not have heard Canopus either. Sirius is very high up at this time of the year. It's, for someone where I am in Australia, it's pretty much more or less overhead during January in the sort of mid-evening. Canopus is high up too, again, pretty much overhead, but a little further south than Sirius. And the star Rigel Kentaurus is low down on the southeastern horizon, but it gets a bit higher during the night as the Earth rotates. This star, Rigel Kentaurus, is one of the two stars that make up the Alpha Centauri system. The other one is called Ptolemy. Most people never hear Rigel Kentaurus or Ptolemy. We just call it Alpha Centauri. It's a double star system or binary star system. It's actually a trinary star system. There is a third one. We won't go into that, but Alpha Centauri is what we normally call it. And it and its nearby sibling called Beta Centauri, that's imaginative, isn't it? Together they are known as the two pointers, or just the pointers, because if you draw an imaginary line through them and extend it further out, it sort of points towards the Southern Cross. Now let's look at the planets. So what have we got? After sunset, Saturn can be seen about 25 degrees up from the western horizon. In the sort of end of the twilight glow, it's brightish. Got a slightly yellowish tinge. If you can get a telescope onto it, even a small one, you'll be able to see the rings. Jupiter is in the same part of the sky. It's about 40 degrees up, so about twice as high up in the sky as Saturn is, but around towards the northern horizon rather than the western horizon. And Jupiter is very easy to spot because it's really quite bright. It's a very big, bright object. What else we got? So Venus. Now, if you want to see Venus, you have to be a night owl at the moment or a very early riser, because it's rising over the eastern horizon just before around about 4 a.m. So, that's an awkward time of the night to be looking for it. But again, with Venus, you can't miss it because it is so big and bright. By about the second week of January, Mercury, the planet Mercury, makes an appearance in the morning sky too, rising sort of underneath Venus about half an hour later. And each of those planets is then followed about half an hour after that by the planet Mars. Now, Venus is big and bright. Mercury's tiny and sort of brightish. Mars is brightish and has a orangey-reddy sort of colour. So that one's easy to distinguish. And what you'll find as the weeks go by this month, during January, Mercury and Mars will appear to get closer and closer and closer together. They're not actually getting closer together in space, of course. It's just a line of sight effect that we see from Earth. And something spectacular will occur in the pre-dawn sky on the morning of January 28, because Mercury and Mars will be right next to each other. Just right next to each other in the sky. It's going to be really spectacular to see. And with Venus not far above them, it's going to be a really spectacular scene to see all those three planets together. So if you get a chance, January 28 in the morning, get up early and have a look, and there you go. Sort of a triple planet extravaganza. And that, Stuart, is the sky for January.
That's Jonathan Nally from Sky and Telescope magazine. And this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.